Group 10, and our topic is database design for cafe food ordering system in UTM. I'm Kohan from S1G2.
I'm IB bin Muhammad Nazim, Lahir Muhammad Nazam from S1G2 also.
My name is Muhammad Shafiq Azrin bin Zainora from S1G2.
I'm Muhammad Hanif bin Ayub from S1G2.
I'm Muhammad Zain bin Muhammad Azlan, also from S1G2.
So about our project, the cafe food ordering system is a digital solution that we designed to modernize the current old paper-based food ordering system at Cafe Lasari. We took Cafe Lasari because this is one of the famous cafe in our UTM, even though the Lasari is just a voice hostel. The system aims to automate key tasks such as order taking, tracking, and management to minimize human errors and improve service speed. By using a user-friendly interface, customers will be able to place their orders digitally while cashing and easily view and manage incoming orders in real time. Through this system, we hope to improve operational efficiency, ensure order accuracy, and provide a more convenient experience for everyone at the cafe.
So next is about the problem statement. In a food beverage environment, maintaining a fast-paced ordering system is required to uphold a good reputation. Customers come and go depending on how long the food service will be. That's why most cafes and restaurants serve food as quickly as possible. However, maintaining this standard at all times is often impractical. The causes of this issue are due to the following factors, which is the first one is lack of technology in ordering system. The use of traditional paper-based ordering method at the counter often causes delays as customers tend to take time deciding on their order. This result is in longer waiting times for other customers in the queue. The second one is lack of real-time data update. Changes in menu item are not updated automatically. As a result, staff members and customers may access outdated information, leading to confusion and service delay. The last one is lack of efficient data analysis and miscommunication in orders. Human errors are common, especially during peak hours. This mistake may occur due to customer unreadable handwriting or staff member panicking in fast-paced situation. Such errors are often unavoidable and may lead to customer dissatisfaction and the loss of returning customers. So we go to the next one.
Okay, now about the objective. We have 3 objectives for our project, which is implement. The first one is implement a digital ordering system. This is to reduce time for the customer to take the order and wait for the waiter. So customer can just open their mobile app or just order it from that. The second one to ensure accurate data capture. This is used to not get the order mixed up and to make sure the order is not lost. The next and the last one is generate an analytical report for management. This is used for the management to see how the cafe performance on the monthly basis. Now for the next one.
Project scope is, the first one is database architecture. We designed this database scheme to define the relationship between various entities like food type, customer, workers, and prices, and so on. And then second one, for data management, to have to implement the efficient data storage, retrieval, manipulation technique, and to adjust accurate placements of the order by customers. And then user interface. By creating a really user-friendly interface, we could have the waitress and the staff, all the staff to implement facilitate the system in a easier way. And then reporting analytics. By integrating reporting tools, analyze profits or loss, cafe performance. The staff can keep track of the cafe performance of the previous sales and so on. And then finally, system integration. One of our scope is system integration to integrate this digital system and also the old paper-based system by integrating their storage also to make sure that their storage is always full as well. Next.
Now we will talk about the methodology, which is the database lifecycle. The first phase is initial study. In this phase, we analyze the situation at the UTM cafe. The current ordering process is manual, which can lead a slow service, long queue, and human error. The second phase is database design. Here, we design how the data would be structured for the cafe food ordering system. The next is implementation and loading phase. In this phase, the Trust database management system was installed and the database table and relationship was created. The fourth phase is testing and evaluation. Here, the database was testing to ensure it produced a correct result, such as ordering summary and payment calculation. The first phase is operation phase. If deployed, the system would be used by cafe staff. This phase represents real world using where the system generates useful information, such as daily sales report. And the final phase is maintenance and evaluation. Over time, a new menu item may be introduced, a price may be changed, and the new features will be added. Now we will pass to the next person.
Okay, the next one is fact finding. How we gather our data. The first one is questionnaire. For this method, we send out surveys to the staff and the customer to see how the system, the original system that the cafe use, how it worked. And the second one is observation. We observe how the cafe do how the taking order, how the customer take the order. For the next one,
Okay, last but not least is the logical EERD. For this, we use a code notation. Okay, in this EERD, we can see that there's a supertype and subtype for staff. So this we use a supertype and subtype relationship here to handle different employee positions. The D stands for disjoint. Disjoint meaning that it can be either one, but then it can be all at the same time. So you are either a chef or a waiter or a cashier. So the next supertype and subtype is the payment method. We apply the same logic to payments by separating the QR code and the cash. The system is future proof. If the cafe wants to use cash, it can, and if it wants to use QR code, which is technology, it also can. The second is for report. So report has its own ID and report type, generated date and staff ID. So a staff can handle many. It can handle none or many reports, while a report can only be generated by one staff. So next is staff order relationship. So one staff can handle one or many orders, while an order can be handled by only one staff. Next is the relationship for order and customer. Customer can place one order or no orders at all, while a order can be placed by only one customer. So the customer has the name and table number, while the order has its own ID, customer ID, staff ID, order date, order status, and payment ID. So for the order and for the relationship for the order and payment is one-to-one, which is one order can be paid one time and one payment can be handled by one order. So next is the relationship for the order and order product. Order and order product. The associative entity product ingredient effectively acts as a recipe book for the system. It resolves many-to-many relationships. This is why we have the bridge table between product and ingredients. It tells the system that one product requires specifically one ingredient or many ingredients. This allows for automatic stock deduction. So next is the product. The product has its own product ID, category ID, product name, and price. And it has the relationship with category is product has one category, while one category can have many products, one or many products. So now we see product ingredient table. The product ingredient, it has a many-to-many relationship. So that's why it has a bridge table. So this bridge table holds the quantity required for the ingredients inside a product. So next is the ingredient table. The ingredient table has its own ID, supplier ID, ingredient name, unit, cost, and current stock. For this, so it has its own supplier. So one ingredient can have one supplier, while one supplier can have none or many ingredients. The supplier holds the supplier name, supplier phone number, email, and also the address. That's it from us. From from us. Okay, thank you.